All right, so let's have a go at example 19. Example 19 is asking us to show that 1 over n into n plus 1 times n plus 2 is equal to a half over n into n plus 1 minus a half over n plus 1 times n plus 2. Now, the thing about a show is that you can either go from left to right or from right to left. So what I'm going to do is I'm going to go from right to left. So we have a half over n into n plus 1 minus a half into n plus 1 times n plus 2. Now, if I'm adding or subtracting fractions and the denominators are different, I must find the LCM. The LCM is n into n plus 1 times n plus 2. N into n plus 1 into the LCM is n plus 2. So it's a half times n plus 2 minus n plus 1 times n plus 2 into the LCM is n. So it's a half times n. Simplifying the numerator, we'll end up with a half n plus 1 minus a half n. So this comes out to be 1 over n into n plus 1 times n plus 2. So the first thing we're asked to do is to show. I just showed it and it did not take many steps. And the key here is that for a show, you can either go from left to right or from right to left. We're then asked to find the sum of the first n terms of the series. So what I would say here is that the sum from 1 to n of 1 over n into n plus 1. I'm going to change this up a little. R into R plus 1, R plus 2 is equal to the sum from 1 to n of 1 of a half over R into R plus 1 minus a half into R plus 1 times R plus 2. This is the same as saying a half, bring the half to the front, from 1 to n of 1 over R into R plus 1 minus 1 over R plus 1 R plus 2. So let's leave this half out here and start writing down some terms. When R is 1, we have 1 over 1 times 2 minus 1 over 2 times 3. When R is 2, we have 1 over 2 times 3 minus 1 over 3 times 4. When R is 3, we have 1 over 3 times 4 minus 1 over 4 times 5 plus. We can then go now to when R is equal to 1 over, when R is equal to 1 over, sorry, when R is equal to n minus 1, so we have 1 over n minus 1 times n minus 1 plus 1, which is n, minus 1 over n minus 1 plus 1, which is n times n plus 1. And then the last term is when r is n. We have 1 over n times n plus 1 minus 1 over n plus 1 n plus 2. All right, so let us see which terms are going to disappear. Looking at this, you'll see that it looks like all the middle terms are going to disappear. You can see clearly that these disappear. So this more than likely would disappear. This would disappear as well. This would disappear. And this would disappear. So it means, therefore, that the sum of the series from 1 to n of 1 over r into r plus 1 r plus 2 is equal to a half into 1 over 2 minus 1 over n plus 1 n plus 2. All right, so that is what we have. The next thing what we're asked to do is that, so after we find the sum, we're then asked to find the sum to infinity. We're then asked to find the sum to infinity. So the sum to infinity from when r is 1 to when r is infinity of 1 over r into r plus 1, r plus 2. Wherever I see infinity, I'm going to put, wherever I see n, I'm going to put infinity. 1 over 2, 1 over 2 minus 1 over infinity plus 1 times infinity plus 2. Now, infinity times infinity is infinity. 1 divided by infinity is 0. So this is actually equal to a half times a half, which is a quarter. The sum to infinity would be equal to a quarter. So we're asked to find the sum to infinity, and the sum to infinity, let's pull it down like that so you can see the entire thing. The sum to infinity is equal. All right, so the last question in this section is example 20. Example 20 is asking us to find the sum of the first n terms of this series, which is represented by the difference of two terms, and then hence find the sum to infinity. Now, the first part, the sum of the series from r is equal to 1 to n, 1 over r squared minus 1 over r plus 1 squared. This is equal to 1 over 1 squared minus 1 over 2 squared. First term. Second term. Next term. Third term. The n minus 1 term. And lastly, the nth term. All right. So what do we observe? We can observe that these middle terms are going to disappear. The middle terms, they're all going to disappear. And if that be the case, looks like the only two that are left is the first and the last. So this sum would actually be equal to 1 minus 1 over n plus 1 squared. So that's the sum. And the last thing we're asked to do is to find the sum to infinity. We could simplify this if we wanted to. But in terms of calculating the sum to infinity, it's easier if you leave it the way it is. And so the sum to infinity would be 1 minus 1 over infinity plus 1 squared. And this is actually equal to 1 minus 0, which is 1. The sum to infinity is equal to 1.